Good morning friends. This is series of lecture for T.Y.B.Sc Analytical Chemistry semester 6 student, and the course is CH611A. The chapter we are going to study is chapter number 6, flame emission spectroscopy, and the part of the under study is diffraction grating. So what is the diffraction grating, how it works, and what is the in which way the analysis is done. Let us see. Now this is a we can say indication or diagrammatic representation for the diffraction grating. Now here this is the incident beam, and this beam this beam will come from the entrance slit, and then entrance slit gives the beam, and it is incident on the monochromatic device, that is nothing but the diffraction grating or prism. Generally diffraction grating is used as a monochromator in flame emission spectroscopy because it is more advantageous than the prism. Now here this is the incident beam, and this is the refracted beam or reflected beam or diffracted beam, and there are number of diffraction possibilities have given in this diagram. So that is the first order, second order, and third order, and that is -1 order is also. And the angle of incident, then angle of refraction is given here. So this zigzag diagram is nothing but these are the number of grooves that are drawn on the alumina sheet, and this is all about the diagrammatic representation of the diffraction grating. Now this is the theory associated with this diffraction grating diagram. Here the first point, a diffraction grating is a suitable dispersing element that can isolate a selected band of wavelength. So what is the function of the diffraction grating? That it can isolate a selected band of wavelength. So this is most important point. What is the function of diffraction grating? That it can isolate a selected band of wavelength. That means which wavelength we have desired or interested wavelength, that gives the proper diffraction grating, proper wavelength is obtained from the diffraction grating. The second point is that it is prepared by carefully carefully ruling. Ruling means what? The word is there, ruling. This ruling means etching a large number of parallel equidistant grooves upon a highly polished metallic surface like alumina. Now this is the alumina surface, and this alumina surface, on this alumina surface a large number of lines have been drawn, and that lines are called as a grooves. These lines are called as a grooves, and generally 15,000 to 30,000 lines per square inch, or lines if we say instead of lines we can say grooves, that is grooves per square inch. Generally 15,000 to 30,000 grooves per square inch. (15,000 to 30,000 lines per square inch are drawn for ultraviolet or visible region. So generally on this alumina surface, this is the alumina surface, this zigzag motion or zigzag line indicates the that surface is made up from the alumina on the alumina. So this surface is available on the alumina. So generally these lines are nothing. How much? It is a 15,000 to 30,000 lines per square inch are drawn for ultraviolet or visible region. So this is particular line which is very important, because the number of lines that will give the best analysis, or we can say moderate analysis or poor analysis. If the lines are more and more, then we get the best analysis in result. These grooves means what? These lines act as a scattering center. So these lines act as a scattering center for incident rays or radiations, Now whatever the incident radiations that will come from the exit slit, sorry, entry slit, or you can say coming slit, we can say first slit that is provided out, that is placed after the sample, then the grooves acts as a scattering center for the incident radiation. So incident radiation, the radiation which come from the enter slit or first slit, then that rays strike the surface of the diffraction grating. But which surface? That is the alumina surface, and that alumina surface, or you can say whatever the lines that have been drawn on the scatterings on the alumina surface, that acts as a scattering center for the incident rays. Now the diffraction grating work on the reinforcement or constructive interference. So this is the principle of the diffraction grating, that diffraction grating work on the principle of constructive interference or reinforcement. Now whatever the radiations that are incident on the diffraction grating, there is after that there is a constructive interference takes place on the surface of diffraction grating, especially on the surface of alumina, because on the alumina surface number of lines have been drawn. These lines, number of lines have been drawn are nothing but the grooves per square inch, and that gives the best result in the analysis. Now n lambda, that reinforcement or constructive interference has the equation n lambda is equal to 2d sin theta. Now in this equation n is nothing but the order of the diffraction, lambda is the wavelength, d is the spacing, theta is the angle of incident or angle of diffraction. Account of that n lambda is equal to d in bracket sin I plus sin R. This equation is useful to calculate the lambda. Now when the monochromatic radiation is incident on the diffraction grating, the above equation means n lambda is equal to 2d sin theta is useful to calculate a single wavelength only, but rotation of the grating to change the angle of incident, that is I, will bring each wavelength in turn a position to satisfy the equation. This results to give the monochromatic beam. So monochromatic beam is obtained by the rotation of the diffraction grating. So monochromatic beam is useful to calculate the wavelength at a different angle or at the different position of the diffraction grating. Now here the construction of the grating is very costly and difficult. Now we can say the diffraction grating which is used in the flame emission spectroscopy, which for the monochromatic light, which the construction of this diffraction grating is costly and it is difficult to prepare. So for that purpose replica gratings are prepared from an original grating. So replica grating is used, that is nothing but it is prepared by coating the original grating with a film of epoxy resin, which after setting is removed to form a replica. The replica thus obtained is made reflective by aluminizing its surface. So instead of, you have to remember only one point, that if diffraction grating is not can say the instead of diffraction grating, sometimes replica gratings are useful, because replica gratings are easy to prepare and diffraction gratings are not easy to prepare. So it is costly and it is not easy to prepare, that means it is difficult to prepare. So this is all about the diffraction grating. So here diffraction grating is nothing but it is an important part or important constituent or important component of the flame emission spectroscopy, especially instrumentation of flame emission spectroscopy, which is called as the flame photometer. In that flame photometer, flame burner, then wavelength isolation system. In that wavelength isolation system, that is nothing but in that wavelength isolation system, the optic, which is also called as the optical system, which consists of entrance slit, prism or diffraction grating, and an exit slit. So this is the part which is associated with the prism or grating, that is nothing but the diffraction grating. So with this content I conclude this lecture. Thank you very much for your patience listening.